So hello friends, in this video we are going to see the basic derivatives problems. So example 1, y equal to under root of log x plus under root of log under root x. So this is our problem. So now differentiating y with respect to x on both sides. So d by dx of y equal to derivative d by dx of root log x. The derivative goes to both, so plus d by dx of under root log under root x. Okay, so we have to write step by step. I am doing it roughly. So derivative of root x, how we used to write derivative of log x raised to half plus derivative of this also I can write log root x raised to half. So now here you have to consider log x as x, because we have the formula x raised to n is nx raised to n minus 1. Okay, so now derivative of y with respect to x is equal to x is nx raised to n minus 1, which n is half, so log x is x raised to n minus 1, which is half minus 1. So here you will take the cross multiplications and then you will get in the next step. Okay, into derivative which we have considered as x, so log x plus here also x raised to n is half into x, which is log root x, log root x into which we have considered x is log root x, derivative of log root x. Okay, so in the next step you have to write this x raised to nx raised to n minus 1, so log root x raised to half minus 1. So here half minus 1 cross multiplication, 2 will go here, so 1 minus 2 is minus 1 upon 2. Okay, so put it here, minus 1 upon 2 minus 1 upon 2. So half means root x we put, right? So minus means 1 upon root, so we can write it as it is 1 upon 2, and this you have to write like this into 1 upon, it goes down in the denominator, so root log x into derivative of log x is 1 by x, as we have the formula, so 1 by x. Everything is in multiplication. Okay, to avoid the confusion I am putting the bracket, plus half into log root x raised to minus half, so it will go in the denominator, root x, which is log root x into derivative of log root x. So now we have to consider it as x, derivative of log x is 1 by x, the x is root x, into derivative which we have considered as x, which is root x, so derivative of root x. Okay, so here x raised to half, again the same formula, nx raised to n minus 1 will be applied there, rest all you have to write as it is. The 2x I have written in the front to avoid the confusion, into root log x plus 2 root x into root log root x, okay, into derivative of root x. So derivative of root x is 1 upon 2 root x by the nx raised to n minus 1 formula. So 1 upon 2 root x. So again in the next step I'm trying to simplify it. So derivative of d by dx of y equal to 1 upon 2x into under root log x plus 1 upon this whole thing is in multiplication, so 2 into 2 4 root x into root x, x raised to half into 2, so 2 upon 2 gets cancelled, so it remains 1, so which is x raised to power 1 into under root log root x. So this has been simplified further. So that's all. So next question, y equal to tan square log x raised to cube. Okay, so differentiating y with respect to x on both sides. So now derivative d by dx of y equal to d by dx of this whole term, that is tan square log x raised to 3. Remember to put the brackets to avoid the confusion. Okay, so now here considering this whole term as x raised to 2, which we have the formula that derivative of x raised to n is nx raised to n minus 1. So we are going to apply this formula here. Derivative d by dx of y equal to, so now x raised to n, which is 2, n equal to 2, and the x is this whole thing into tan of log x raised to 3, okay, into derivative of which we have considered x, that is tan log x raised to 3. Put the brackets carefully. So now in the next step you have to write this whole thing as it is, 2 into tan of log x raised to 3 into derivative of this term tan, we have the formula of derivative of tan x, which is sec square x, so consider this log x raised to 3 as x, so put the formula sec square x, which is log x raised to 3 into derivative of which we have considered x, that is log raised to log x cube. Okay, so now in the next step you have to do the derivative for this, and rest you have to write all as it is, 2 tan log x raised to 3 into sec square log x raised to 3 into derivative of log x raised to 3. Consider this as x, derivative of log x is 1 by x, so 1 by x log x is x cube, right? So into derivative of which we have considered x, that is x cube. So now in the next step you have to derive this, the x cube, you can do this nx raised to n minus 1 formula, rest all you have to write again as it is, 2 tan log x raised to cube into sec square log x raised to 3 into 1 upon x raised to 3 into derivative of this is nx raised to n minus 1, which is 3x raised to 3 minus 1 is 2. Okay, so now everything is in the multiplication, right? So 3 2s are 6, and then x cube is in the denominator and x square is in the numerator, so it get cancelled out and the remains is x in the denominator into tan of log x raised to 3 into sec square log x raised to 3. Okay, so this we have simplified till here, derivative d by dx of y, which is this. Okay, so next question, y equal to sine bracket cos bracket tan x. Okay, so again differentiating y with respect to x on both sides, I have to write the steps because these steps carries marks. You have to write step by step to get good marks. Okay, and write it in complete sentence. Avoid the shortcuts and also mention the formulas in the bracket. So derivative d by dx of y equal to d by dx of sine bracket cos bracket tan x. Always keep this habit of putting the brackets to avoid the confusion. So here derivative of sine x is cos x. I am considering this whole term as x, so write that whole term x cos tan x into which we have considered x is derivative of this whole term cos bracket tan x. Okay, so now in the next step write the first thing as it is, cos bracket cos bracket tan x into this derivative of cos, consider this as x. Now derivative of cos x is minus sine x, put this x is tan x bracket, this minus is the in between is multiplication. Okay, to avoid this minus we will put the minus in the front in the next step. So derivative of this which we have considered x is tan x. Okay, so in the next step I'm just putting this minus sign in the front to avoid the confusion. So cos tan x into sine bracket tan x into derivative of tan x. We have the basic formula, which is sec square x. Okay, so here this is the answer. You have to write this d by dx of y in each steps to get good marks. Okay, so next question, y equal to sine bracket ax square plus bx plus c. So again differentiating y with respect to x on both sides, d by dx of y equal to d by dx of sine ax square plus bx plus c. Okay, put the brackets again to avoid the confusions. Okay, so derivative of this is equal to, so derivative of sine x we have the basic formula, it is cos x, right? So now we are going to apply this. Consider this whole term ax square plus bx plus c as x. So derivative of sine x is cos x into derivative of which we have considered as x, it is ax square plus bx plus c. Okay, so in the next step we are going to derivate that. So first thing, cos ax square plus bx plus c as it is we have to write in the next step. Okay, into derivative of this, so derivative will go inside all three. So derivative of this, a is the constant removed outside, derivative of x raised to 2 is 2x raised to 2 minus 1 is 1. Here we have applied the formula nx raised to n minus 1. Again derivative goes inside, b is constant, it comes out, derivative of x is 1, c is constant, gets out, derivative of constant is 0, so it is 0. Put the brackets to avoid the confusion again. So the next step, write cos ax square plus bx plus c into 2ax plus b. This remains. Okay, so this is the final answer. D by dx of y is this. We have tried to simplify it till here. So next question, y equal to root of a square plus root of a square plus x square. Differentiating y with respect to x on both sides. Write this everywhere, full complete sentence, okay, to get good marks. So in the next step you have to write d by dx of y equal to d by dx of this whole term, root of a square plus root of a square plus x square. Okay, so here you are going to consider this whole term as x, as we have the formula derivative of root x is 1 by 2 root x. Okay, so put this here. So equal to d by dx of y equal to derivative of root x is 1 by 2 root x. The x we have considered is this thing, a square plus root of a square plus x square. Done. Then into derivative of which we have considered as x, the whole term you have to write here, a square plus under root a square plus x square. So in the next step we are going to derivate this, equal to 2 root a square plus under root of a square plus x square, this whole term into, so derivative goes for both sides, a square which is constant, so derivative of constant is 0 plus this good derivative goes to there also, the bracket is important. So derivative of again the whole term is root a square plus x square so now here again we are going to do the x raised to n formula. Write this as it is, okay, 2 root a square plus under root a square plus x square as it is, we have to write into derivative of this, it goes to the both sides. So derivative of this is, I'm going to consider the whole term as x, root x is 1 by 2 root x, and here x we have considered is a square plus x square. Okay, so this into bracket d by dx of which we have considered as x is a square plus x square. So the next step that going to be derivative. So this whole term as it is you have to write 2 under root a square plus under root a square plus x square into 1 upon 2 root a square plus x square. So derivative of this bracket, derivative of constant is 0, derivative of x raised to 2 is 2x. Okay, so now 2x 1 upon 2 root a square plus x square goes to both, so that we get as root 2x upon 2 under root a square plus x square plus under root a square plus x square bracket into 2 under root a square plus x square. So here the 2 gets cancelled and the final answer we have simplified is derivative of d by dx of y equal to x upon under root 2 under root a square plus under root a square plus x square, this thing in the bracket into root of a square plus x square. So till here we have simplified it. So that's all. Thank you.